So hello guys, today we are going to do a lead code question that is of linked list. And what is the topic, like what is the heading of the question is reverse linked list. It is question number 206 and it's saying reverse linked list. So first we'll start by reading the problem statement, what the problem statement says. So I'll start by reading the problem statement. It says that given the head of the linked list, single linked list, reverse the list and return the reverse list. The problem is quite simple. You are just given a linked list. You are just given a linked list. If you don't know what a linked list is basically a collection of nodes. A collection of nodes that are interlinked by a linker, that is interlinked by a linker, is known as a linked list. The end contains a null value. And what is a node? What is a node? If I say what is a node, it is basically a structure. It is basically a structure that consists of the data and pointer to the next node. Pointer to the next node. So this is basically what a linked list is. So what I'm given is if I come back to the question, given the head of a single linked list, reverse the list and return the reverse list. Okay, so if I am given a linked list like this, 1, 2, 3, I'll just have to reverse it and I'll have to return 3, 2, 1. So the last node becomes the first node, the middle node remains the middle node, and the first node becomes the last node. So I have reversed the linked list. I hope there is no doubt in the question in the problem statement. So I'll start by just the brute force solution that can come to my mind. What is that? So if I consider this linked list, so what is the brute force solution that comes to my mind? How can I reverse it? How can I reverse it? Okay, for suppose if I have what is the task that I have to do? I have to make the I have to make the last element the first element. I have to make the last element the first element, and then I'll have to move towards the front, and I have to store each of the element in traversal. But you know that we can't traverse a linked list backwards. We can't traverse a single linked list backwards. So what can I do? What can I do? Suppose suppose if I am given this linked list 1, 2, 3, and 4, how can I reverse this? How can I reverse this? Well, we can reverse it by like simply declaring a vector. Maybe vector helps. So what we'll do is we'll simply declare a vector, and I'll store all of these values. I'll store all of these values in the vector. Like I'll declare a vector of the same size as of the linked list, and I'll store each of these values in the vector. Like I'm traversing the linked list. My temp pointer is here. I'm traversing the linked list, and what I'm doing is I'm storing the first value in the first position, the second value in the second position, the third value in the third position, and the fourth value in the fourth position. So this becomes my vector. So my vector will be the identical copy of my linked list. Copy of my linked list. So what I can do is I can just simply reverse the vector. I can just simply reverse the vector. So the vector becomes like this: 4, 3, 2, 1. So as you can see, the vector has become. I'll just use the reverse function, the reverse built-in function that reverses the vector v dot begin and then v dot end. So it will just make the vector reverse, and I'll again traverse the linked list. I'll again traverse the linked list along with this reverse vector. And suppose I have this linked list 1, 2, 3, 4 is stored in these positions. I'll simply traverse the vector, and as I traverse, I can override these values. I can override these values with the current value that I am on in the vector. So if I am on the first position in the vector and I'm on the first position in the linked list, I can simply override the one. I can simply override the one with 4. I can simply override the one with 4, and it is as simple. As we can see, the first step is done, that we have made the last node as my first node, and now I'll traverse in the front. Okay, I'll move one step ahead. I'll come to the second node. I'll come to the second position in the vector, And what I'll do is I'll simply copy it into this position. I'll just override it. So this becomes 3, this becomes 3. I'll move forward, I'll do the same thing in the next position. I'll just copy it, I'll override it, and I'll do it for the whole vector. I'll do it for the whole vector. So if I see that what my linked list has become, my linked list has become like 4, 3, 2, 1. So it is the same linked list that we wanted to get. It is the same linked list that we wanted to get, because the reverse of this linked list 1, 2, 3, 4 is gonna be 4, 3, 2, 1. 4, 3, 2, 1. I'm using an extra space. That is a vector, and I'm storing all these values in the vector, all the linked list values in the vector, and I'm reversing the vector. I'm reversing the vector. I'm reversing the vector, and I'm again overriding the current values. With the vector values, the values contained in the vector. As my vector is reversed, so the values would also be reversed. The values will also be reversed. So now my linked list would automatically contain my reversed values. My reversed values. So this can be one approach towards solving this problem. If I discuss about the time complexity, so I am traversing the loop once. For just storing these values. So it is O of n, and for reversing, if I use the two pointer approach, suppose I am again using O of n time. So this O of n and this O of n, okay, 2 into O of n as of now, and for storing the values again, I am again using an O of n. So it becomes 3 into O of n. That is the time complexity. 3 into n. Okay. And what about the space complexity? My space complexity, as I'm using a vector, and that vector is gonna be the same size of my linked list. So the space complexity, if my linked list is of size n, then the space complexity is gonna be O of n. I'm overriding the values in the current linked list, so the linked list space doesn't count. So the space complexity would be O of n. Oh, it is a higher time and space complexity. So can I optimize this? Yes, I can do. But how? I'll say that if I tell you that there is a better approach towards solving this question, that is, there is an optimal solution to this question, that solves it in O of n time and O of 1 space. Okay, so I have brought down my time complexity from 3 into n to O of n, and space complexity from O of n to O of 1. So is there any solution that exists like this? Okay, we'll see. If I come to an optimal solution that I'm going to tell, suppose consider this as my linked list. 1, 2, 3. Okay, 1, 2, 3, and suppose 4. This contains 4 values. I am saying that what I am doing in reversing my linked list is actually, if my current node is pointing towards the next node, I'm just simply, if I just simply erase this connection, and make it point to the previous node, and do it for all the elements, then my linked list would be reversed, right? Suppose if there are two nodes, and if I want to reverse this linked list, how I can reverse this? I'll just simply erase this connection. And what I'll do is I'll make the first next node point towards the previous node, and I'll make the 2's next pointer move towards the previous one. Okay, so this would become 1 and 2. So the pointer location would be changing and it would be onto the previous element. This is what I am supposing to do. This is what I am supposing to do. Okay, so if 1 2 3 exists, what I'm trying to do is I'm trying to reverse this length. I'm trying to reverse this length of all the ones. Here also 1 exists because null value is here. So next pointer exists for this also, for the last node also. For achieving this, I would have, if you say that I can do this with one pointer, if I consider one pointer, I'll tell you how we reached. We'll be using 3 pointers at all. We will be using 3 pointers in total, but I'll tell you how we got the 3 pointer solution. How we got the 3 pointer solution. So, if I want on my current element, this is my pointer. My current pointer is here. If I tell you, if I use only one pointer, then how can I reverse this list? Can I reverse this? Okay, what my target is, I want to make this pointer point to the previous position and remove the link from here. I want to, if this is my linked list, I want to remove this connection and make it point to the previous position. So I want to make this. But if my current pointer is at this position, how would I know the previous element? How would I know the previous element? I don't have any pointer or any respect to this position. I don't have any respect to this position. I don't know that there exists a position before this pointer, before this current node. So I cannot use one pointer. Because for pointing this to the previous element, I should know the previous element as well. I should use the previous element as well. Okay, makes sense. So one pointer technique is failed. I cannot reverse the link using one pointer. Okay, because I want to know the previous element also. My current pointer would be pointing here. I would need at least 2 pointers as of now. I will need at least 2 pointers as of now to make it reversed. Okay, so we have come from 1 pointer to 2 pointers. Okay, so I am assuming as of now that in 2 pointers I can reverse the list. Okay, I am assuming. It can't be done. I am just assuming. So if this is my linked list, and my current pointer is here, and my previous pointer has some value null. Okay, has some value null. So if I say that I'll reverse this position, I'll reverse this pointer as it is pointing, as the first pointer is pointing towards the second node. I want to just reverse this. Okay, I'll reverse this and I'll make it point to the previous position. Okay, I can do this. I now know the previous element. So I'll make the currents next to be the previous element. Okay, makes sense. Because now I know the previous position, I can modify the next pointer to point at somewhere here. That is the null position. So now I know the current element as well as the previous element. I can switch this position. But now I have switched this position. Suppose I have switched this position. I was at the first element, second element, and third element. I'm at this case where my second element is now pointing to the third node. My second node is now pointing to the third node. Okay, and my current node is pointing to the previous node. My current node is pointing towards the previous node. Now I don't want to do for this node only. I'll have to reverse the whole list to get the reverse list right. So if I want, I can do for the first node. If I want to do this for the whole list, now if I want to do current is equal to current next, if I want to get to the second node, so if I do currents next, I want current to go to the next position that is it has. So it will now go to the previous node. It will now go to the previous node, as it has made a connection with the previous node and it is now not pointing towards the second node. So as it is not pointing now towards the second node, so my current node would point to, as my current node is now pointing towards the previous node. So if I increment my current pointer, it will go towards the previous node. It will go towards the previous node, as it has lost connections, as it has lost connections with the second node. It doesn't has any connections with the second node. So this list is lost. This list is lost. So what I can do is to overcome this. What I can do to overcome this. Remember, we failed the one pointer technique. We failed the second pointer technique. We failed the second pointer technique. Two pointer technique. Okay. So we failed the first pointer. We failed the second pointer. Okay. I'll try to add the third pointer. I'll try to add the third pointer. And what I'll say is, if this is my linked list, and my current is pointing here, my previous is pointing here, I say that I will also store the pointer that is next to the current pointer in my third pointer. So my ahead, the variable that the pointer name is ahead, will store the value, will store the node that is at the next position of the current pointer, that is at the next position of the current pointer. Suppose my current is at the value 1, so my ahead will be one place in front of the current pointer, in ahead of the current pointer. Okay. So if my current pointer is pointing at 1, my ahead pointer will be at 2. My ahead pointer will be at 2. Okay. So if I use 3 pointers, let's see if we can make it or not. If we can make it or not. My end goal is to reverse all these links. My end goal is to reverse all these links from to make it from 1 pointing to 2 and pointing towards the previous element, I'll have to make it point towards the previous element. Okay, so this is my end goal. Let's see if we can achieve it or not, or we will need 4 pointers. Maybe if we fail this condition, we will need 4 pointers. Who knows? Okay, so I'll just try to dry run it, whether it works or not. If my current pointer is here, my previous pointer is here, and my ahead pointer is here, So what was my first step? I'll just delete this connection with the second node and make the current pointer point towards the previous pointer. I'll make the current pointer point towards the previous pointer, because that was my concern. If my pointer is pointing towards the second node, if I am at the first position and my pointer is pointing towards the second node, I want the first pointer to point towards the zeroth node. So then only my list can be reversed, and I have to do this for all the nodes. I have to do this with all the nodes. Okay, so this is something we had done till the previous step. 2 pointers was able to fulfill this condition. What was the problem in the 2 pointers solution was that I was not able to get the next position that I wanted to go on to perform these steps again. So what I'll do is, after I have made a connection to the previous pointer, I'll increment the previous counter and make the previous counter point to the current pointer. I'll make the previous counter point towards the current pointer. Okay, and I'll make my current pointer equal to the ahead pointer, because now my first node knows that I have a connection with 0 and I also have a pointer at the second position that is telling me that this is the way you have to go. You have to go. My end goal is to reverse the linked list while there is someone who is guiding me that this is the path and this is where I have to go. Okay, so ahead pointer does the work of this guide. Does the work of this guide, who basically tells me that this is the part that you have to follow. Okay, so when I have made my previous pointer as my current pointer, I'll make the current pointer to point towards the ahead pointer. I'll go towards the saying of the guide. Okay, I'll just go to the second pointer. I'll just go to the second pointer, and I'll do the same thing again. I'll do the same thing again. Okay, now also my ahead pointer, is pointing towards the next position, because my guide has told me the first way to go to, but he has to tell me the whole way to the destination. Okay, so whole path to the destination. So he will move one step ahead. He has told me one path to take. Now he'll tell me the second path. So he is incrementing his position. Okay, so my ahead will go ahead. Ahead will go one step ahead. Okay, so my current pointer becomes this, and my previous pointer takes this value. So what my current pointer has to do now, it will now point towards the previous pointer. So my current pointer is now pointing towards the previous pointer. I have done the work. I have made the previous pointer to reverse its link, and I have made the current pointer also to reverse its link. Okay, I'll make this. So for this step also, I have reversed the link. I have made the second pointer to point towards the first pointer, and the first pointer already knows that it is connected to the 0th position. Okay, so I'll increment. I have my work done. I'll increment this. I'll make the current to point to the next position. Okay, if I make my current pointer to point towards the ahead position, okay, this position. So if I try to make the previous pointer at that position where my current pointer was, so it would be lost. Why? Because as I have incremented my current pointer, now if I want that my previous pointer should be equal to the current pointer, it will be now equal to the ahead position. So this will point at the same position at one time. If I increment my current pointer first, so what I'll do is first I'll make the previous pointer to occupy the space of the current pointer. So my previous pointer would first point here, and then my current pointer would go to the next position, the ahead position. Okay, so now my current pointer points here, and ahead is a guide. He'll go forward. Okay, so my ahead goes forward. Ahead is pointing now to the null position. Okay, so my current is at the third position, my previous is at the second position. I'll do the same thing again. I'll try to reverse the link. I'll make the current to point towards the previous pointer. Okay, and I'll increment the previous counter to point towards the current, and I'll increment my current pointer to point towards the ahead pointer. Okay, so my current goes to the null value, to this value, and my previous pointer goes to the last value in the linked list, Okay, now I don't want to move forward. I have done my work. I haven't have to go forward, because if I go forward, I'll get lost of this link. I will not able to get the first node in the linked list. I will not able to get the position of the first node in the linked list. Okay, so when my current pointer would be pointing to the last position, that is the null position, I'll stop, because I have to know the position. I have to know the position of the last pointer. I have to know the position of the last pointer, the last node. Because now as my links is reversed, so my 3 is pointing to 2, my 2 is pointing to 1. So my previous would be here, my current and ahead would be here, okay. So if I increment my pointer here also, I'll lose this head, okay. So I'll lose my whole linked list. So I will continue only to that point where my current pointer is not equal to null, okay. So if my current pointer becomes equal to null, I stop. Why I should stop? Because I don't want to get don't want to get this linked list to be lost, okay. So I'll just stop the iteration. Okay. So I have done my work. I have made the links to reverse. My third node is pointing towards the second, and my second node is pointing towards the first, and my first node is obviously pointing towards the null position, okay. So as you can see, and as we have iterated, my previous node would be here. So the node that I will have to return would be the previous node. Okay, this is the node that I will have to return. Makes sense? So this is the current pointer and this is the ahead pointer. Okay. So I'll return the previous node, and what I'll get as the previous node is my head of the modified linked list. So here ends my iteration. If I try to write the code for this, this case can also occur. Suppose my head is equal to null. That is, my linked list is empty. My head is pointing towards the null position. So I'll just simply return null, because I can't reverse a null position. Okay, makes sense? If there is no linked list, there is nothing to reverse. So I'll just simply return null. Another case is when my linked list contains only one node. If my linked list contains only one node, then there is nothing to be reversed. That is already reversed. That if there is only one node, if there is only one present, there is no need of reversing, right? One is also the same, and the reverse would be one that would also be the same. So there is no need of reversing. So I'll make the edge cases to mention here. If my head is not present, my linked list is not present, I'll return null. If there is only one node, I'll just return the head. Now I'll try to make the 3 pointers. See, now we have done reverse the list with the help of 3 pointers. So this is how we got onto the third pointer. We are able to reverse the list with the help of 3 pointers, not 1, not 2, but 3 pointers is the minimum I need. Maybe using more pointers you can reverse, but 3 pointers is the minimum that you can use to reverse a linked list, or you would end up increasing the time and space complexity. Okay, so coming back to the code, I'll make the previous pointer, I'll make the current pointer to be the head, and I will make the ahead pointer to point to the second node. Okay, I'll continue till my current exists, because if my current is at the null position, then only my previous will be pointing at the last position, and I will return my previous. because my now the previous pointer is now the head of the linked list. Okay, so I'll make the current's next pointer to point at the previous pointer, and I'll increment my previous pointer. I'll increment my current pointer to point at the next position, because my both the pointers have to increment their position. My previous pointer has to come towards the current pointer, and my current pointer has to go to the next pointer. Okay, and this ahead guide will obviously be 1 point ahead. Okay, so if I return the previous pointer and try to run it, if I return, okay, and this also, if my current pointer is at the last position, if my current pointer is at the last position, for that case also, if this is my end of the linked list, this is the last element in my linked list, and my current element is pointing here, so my ahead would be pointing at the null position. So if I try to increment this count, then it would give an error, because the pointer doesn't know what memory is this allocated for. So it can't increment its count, it can't increment its count. So I have to add a case that if my ahead exists, then only increment its count, then only move its pointer, else doesn't move, else it shouldn't move. So as we can see, the code has run, and if I try to submit it, okay, the code has been submitted successfully. So if I try to summarize my code, what I have written is, if there is no node at all in the linked list, so I'll just simply return null, because if there is no linked list, there is nothing to reverse. If there exists only one node, then I will simply return that node, because if there is only one node, there is nothing to reverse. So there can be only one node that can be reversed, so that can be returned as it is, right? And this is what I am doing with the 3 pointers. I am declaring the previous, current and ahead pointer, and I am making the current pointer to point towards the previous current pointer, that is the middle pointer, to point towards the previous pointer every time. And then I'll increment my current pointer to do the same for the full linked list. Okay, so if I come to the time complexity of this question, I am just moving the current pointer once. So the time complexity becomes O of n. And what about the space complexity? As I'm not using any data structure apart from the pointers that I'm using, so my space complexity becomes O of 1. So as you can see, I have reduced the space complexity from 3 into O of n to O of n, and my space complexity from O of n to O of 1. Okay. So this was the solution that I wanted to discuss. Hope you liked the solution. If you have any doubts, you can comment. And thanks for watching. Bye bye. Take care.